Hello again from KB America. Today I wanted to talk to you about the basics of a VFD and how it uses pulse width modulation to convert a 480 volt 60 Hertz AC input to a variable voltage, variable frequency AC output to a motor. Alright, so this is kind of a general overview of a basic VFD system. And to go into a little bit more detail, the first part we have here is the converter section that takes your 480 volt AC 60 Hertz input and converts it into a DC voltage. So your DC voltage will be 480 volts, your input, times the square root of 2 or 1.41, which leads to 678 volts DC. And that leads us to the next section, which is the DC bus. So that is a capacitor bank that allows you to smooth out your DC voltage and allows for some voltage storage capacity. So your final section is the inverter section. That has 6 insulated gate bipolar transistors, or IGBTs, and that takes your DC bus voltage and converts it back into a variable voltage, variable frequency AC output to the motor. And so now we'll go into a little bit more detail on this inverter section. So pulse width modulation uses IGBTs that are switching on and off up to 16,000 times per second to convert your DC bus voltage to an AC output at the motor. So a typical configuration is shown here with 6 IGBTs, 3 on the top and 3 on the bottom. Depending on which are open affects how which phases you go through and in what direction. So in order for current to flow, one of these transistors from the top and one from the bottom need to be open. So for example, if we start over here and run through this transistor, we can go through the U phase, down through the V phase, and back out here. So with these two transistors open, we go through the U phase and then through the V phase and then back out to the DC bus. Alternatively, to show how we can go through the same U and V phase but in reverse from V to U, we would go through here, through this transistor, down here, and so this time we're going in the opposite direction through V to U, and then now we go down and out here. So this is just one quick example to show, depending on if this one or this one is open and this one, we can go through the U and V phase in either direction. Similar configurations hold going through U, V, and W in any direction. So next we'll get into how the width portion of the pulse width modulation affects your RMS voltage to the motor. So we covered how the pulse portion of the pulse width modulation is the switching on and off of the IGBTs. Next we're going to dive into the width portion. So because your DC bus voltage is 678 volts DC, each pulse of the IGBT produces an amplitude of 678 volts DC. We can affect the RMS voltage on the output by changing how long the pulse is on and off. So as you can see here, we have a longer on period and a shorter off period, so that produces an RMS voltage with a higher amplitude. And that's opposed to this diagram down here, where we have a shorter on period and a longer off period, so our RMS voltage will be much smaller. So even though we have the same 678 volts pulse, by changing the on and off lengths, we can affect how high the RMS voltage to the output is. So that's the variable voltage portion of the AC output. So on the variable frequency portion, what we do is we keep these on and off ratios the same, but we squish them all together so it's happening much more quickly. So we have the same RMS voltage peak, but it's just occurring much more often. So by changing this variable voltage and variable frequency output, we can keep a constant torque at the motor output while getting more power out of the motor. And so that's kind of a basic overview of a VFD system and how it uses pulse width modulation to maintain constant torque while increasing the power of a motor.